Much.
Good morning, everyone, and thank you for coming along to my talk. Delete 99% of your code. That's a pretty big claim. If we have 100 lines of code, we can delete 99? Well, probably not. There's lots of things we can delete, configuration code, every code, but we're going to have a look at this, and maybe I'll try and convince you that we can meet this big claim. Before I start, I want to talk about things, what could make this possible? Once in a while, someone comes along with a new idea or technology that's a radical innovation. This means it's not just incremental or disruptive, it actually changed the meaning of something. Like the iPhone changed what it means to be a phone. What I want to talk today about is something which I think is a radical innovation in enterprise systems. Can change the way you think about an enterprise system. I think it can be revolutionary as well, but also that, of course, revolutionary has its negatives as well, keeping up with things and changing. From my understanding, it certainly solves many pain points and complexity things that I see in current back-end enterprise systems. I think it is a paradigm change. It's not a low-code environment, it's not vibe coding, it's real technology, a real platform. To be clear up front though, this is not my invention, my technology or my product. It's not a secret, although it's just come out this year. But I'm very excited to discuss it with you and explain it to you and help you understand it today. Let me start with a personal story though. A little over 10 years ago, I started my third startup, and it was going to be a global enterprise. So I decided that I didn't want to start in PHP or Ruby on Rails and then have to change to some other platform later to be global scale. So I decided to choose a technology and platform that would scale, but start off small and then I could eventually scale. Unfortunately, it didn't go so well. We had $100,000 from Google for infrastructure, and my wife and I invested much more than that in the venture. But it failed. We also had a small team, but it still failed. So why did it fail? Well, there were lots of reasons, but part of it was we spent too much time on all that grey code there. The infrastructure, setting up things, getting it working, maintaining things. When really we should have been focusing on that one line of code down there, which was the business value, which really delivered to the customers. In fact, we didn't actually get to deliver anything to the customers because we ran out of money and time because of all that infrastructure costs. Could we have avoided that? That's what I want to talk about today. So, a little bit of an introduction and overview here. The stuff for my talk, I want to talk about the pain that is enterprise systems development these days. I want to talk about the promise that this platform offers, and hopefully show you the payoff it can give. And we'll finish with some Q&A if there's time. A little bit more about myself. Now, I have three main passions, everything to do with IT, startups and AI. I have over 30 years experience in IT. I'm a full stack developer, front end to back end. I tend to focus on enterprise-driven architecture, event-driven architectures and CQRS. I offer consulting services for startups and also work as a practitioner and consultant in IT. I also run the Lean Startup Perth meetup if you're keen to learn about that. And I've worked on multiple startups, as you can see here. The last two are the top ones up there that I'm working on currently now. But enough about me. The real genius behind the presentation today is this gentleman, Nathan Mars. He's the founder of Red Planet Labs and the creator of the platform that we're going to talk about. He spent over 10 years developing this platform. He worked at Twitter for a couple of years, which is relevant, and developed a number of technologies that are used widely in the enterprise today. So he's the genius, he's the one who built this stuff. Before I go on though, I should say I'm in no way affiliated with Red Planet Labs, Nathan Mars or the Rama platform. I'm not even an expert in this platform, though I'm hoping to use it. I'm just excited about the technology and the opportunity that I think it offers to enterprise development. Before I start, I should thank our sponsors this year. These are the people and the companies that make our conference possible. So thank you very much to all the sponsors for DDD Perth 2025. Okay, so I hope you've all had your morning coffee. My presentations tend to be a bit fast and furious. There's lots of things to get through and not much time. I hope you can keep up, and I hope you find it interesting, worthwhile, and enjoyable. Okay? So hold on tight, let's go. So what is the pain of enterprise systems development? Do we have any enterprise system developers in the room? Put your hand up. It's the back-end side of things. Okay, quite a few, that's great. So hopefully you'll understand this. But what are we talking about in enterprise systems? So we have the front end and the back end. We're focusing primarily today on the back end of the systems. If you only have a small back end, it's probably not relevant, but you have a large back end, you want to scale, you want to be fault tolerant, then this is a talk for you. The sort of systems we're focusing on are things like ERP and CRM systems, shopping systems, order systems, payment systems, banking systems, finance systems, message and chat systems, multiplayer game systems, even IoT control systems, things that have to be scalable, fault tolerant, and reliable and performant. We're not looking at front-end applications like web front ends or spas. Unfortunately, we can't delete your code there yet. Or mobile applications, but maybe come along soon when we could do that. Or high-performance computing, or if it's a simple back-end, just basic CRUD stuff, maybe this is not relevant. So similarly with hard real-time applications. But there's a lot of applications fit in this side here, and because we're global these days, lots of applications want to scale and they need to be fault tolerant, so I think this covers a lot of enterprise-type systems. Now, when we evaluate enterprise systems, we look at a number of qualities at the top there, the green things. We'd like our systems to be scalable, which means you can handle more load or more customers without re-architecting your system. We want it to be fault tolerant, so if part of the system fails, the whole system doesn't come down and you can fix it and get back providing full service. High availability, reliability, durability. These are all the qualities we use to evaluate enterprise systems. And often these enterprise systems use mechanisms like the ones below to actually provide these qualities. They have replication, redundancy, partitioning, sharding, back pressure in their streams, and so forth. So we can evaluate an enterprise platform by how green it is above and how much it provides down the bottom to support that. Similarly, from a developer's perspective, you want to know how easy is it to develop on this platform. And there are a number of qualities above. How consistent is the platform? How easy it is to maintain your software? How much clarity you have? How extensible is it? And so forth. And what's the learning curve like? Is it a big learning curve or a small learning curve? And these are often developed by the mechanisms below. For example, if there are a minimal number of abstractions for your system, it makes it easier to understand. If you can use compositionality to compose things rather than building everything from scratch, that's also great. So we can evaluate a platform, like the one we're looking at, according to these qualities as well, and we'll do that as we go along. But really, what is this pain? The pain is, as I mentioned in my startup, of non-value delivering work. I'm working on some enterprise systems at the moment, and the teams who work with us, you can see a large percentage of their time is not value delivering. We're trying to adopt or use SAFe and the Agile framework and Scrum, which is about delivering value quickly to the end users, not after 3 months of deployment and installation and maintenance and setup and so forth. And I see a lot of the teams are doing most of the stuff which is not value delivering. Of course, it's valuable work, but it's not delivering value to the customer or the user. So that's the pain in enterprise development. So, the installation, the setup, the configuration, the maintenance, the glue code. It's a very large part of the work that enterprise developers or the teams do these days. So how did we get into this situation? Why have we got this complex situation? I want to look at the evolution of enterprise systems. How did they start? Well, a long time ago, we just had a server application. And maybe you had a batch system, or maybe you had a teletype, you could talk to it on a terminal. Didn't even have a database. They saved things to files. But after a while, it wasn't performant, so they added a relational database. And you'd connect from your teletype, would talk to the database through the server application. And then we thought, we don't want to use teletypes, we want to have rich client applications. So we added client applications on, which usually talk directly to the relational database or the server application in the middle. And then, of course, we had more clients, so we had to have a web server in there, make them thin clients, so we wouldn't all be talking to the back end directly, we'd go through the web server. And we then have to have extra server applications because now we're getting lots of clients. We need more server applications. So we need a load balancer thrown in there as well. And then you need an orchestration platform to run the applications on different servers and control them and so forth. And then you need some data model mapping. You know, you're developing in OO, but your database model is relational, so we have to map between those, extra work to do. And you have a query cache because your database is still the slow point in your application, so you don't want to slow down the application waiting for a database query or so forth. So we put a cache in there. And then we put in extra databases to try and speed up things. And we added in some NoSQL databases. And as you can see, it goes on. We have an API gateway for mobile applications. We have a message broker. We have pub/sub. We have lots of things on the front end. We have a workflow engine on the back end, and so on and so on. And we eventually added data warehouse and analytics. So this is the status of an enterprise application that's scalable and fault tolerant and so forth. All of these components connected together. And you really can't say these modern enterprise systems were designed up front to be distributed and fault tolerant and scalable. We sort of added on things to make it work. And we're still doing that a lot of the time, adding on things, tacking them on, hacking the systems. Lots of architectural decisions you probably shouldn't have to make, and you don't want to make. You want to focus on delivering value with the business code. So, what can we do about this? As I say, we're generally attitude-ing it to it, not simplifying it. That is, until now, what we're going to talk about. Just for interest, this is the architecture, you probably can't see that, of our startup. This is the structure we had there. And as you see this bottom left bit here, for each of the grey boxes, the subsystems, there was a copy of that. So in the startup, we were trying to manage all these different applications and stuff running on different servers and communicating and so forth. No wonder we didn't get to deliver value. But over the years doing enterprise systems, I've seen that after a number of years, even if you start off with that big mess, I won't go back through that, here, after a while, if you squint your eyes and have a look at this, it tends to actually evolve into one particular direction. The systems tend to evolve into something what's called CQRS. You may have heard it. It stands for Command Query Responsibility Segregation. What it means basically is your system is structured to handle a whole lot of commands coming in from the clients. Deposit in the bank account, withdraw or transfer. And then you get those commands and you handle them. You validate the command and you do what it says. And when you do that, you sort of update the database, the persistence. That's called the write side of CQRS. And we optimize this for writing. Now, the other side of a system is the read side, where you've got queries coming in from your customers or your interfaces or your mobile clients, and they want to get information out. And it's too slow to actually go to the database directly, so we have something like a view updater, which makes these separate views tailored for each query. So every query is just get a row from a database, here's the answer. And if you look at enterprise systems, you squint your eyes, even though they're a mesh, most of them are trying to do this. I'm a big fan of CQRS and presented at DD Perth before on CQRS, why I think it's the architecture we should use for enterprise systems. But there's still quite a bit of moving pieces in there. And my architecture for my startup tried to use this approach. As you can see, it was still quite complex. But if we look at this enterprise approach, the CQRS approach, there are sort of 4 capabilities, the essential parts of an enterprise system. Number 1 is what we call the command bus. That collects those commands from the client, deposit, transfer, withdraw, and it queues them up because maybe they come in faster than we can process. So you want to put them in sort of a queue. And then there's the command handlers. These basically take the next command off the queue, validate it, it's a sensible command, do it if they wish, and update the database, and that's handled that command. Then go back and get the next command. That's the sort of write side. On the read side, we have those queries I mentioned, and we have these things called views. Views are sort of the data structures set up just for the queries. And basically want to be able to efficiently query the system and get back an answer as quick as possible. And lastly, number 4 is event processing. We want to basically respond to events outside our system and send events to other systems. So these are really the 4 essential things that I think every enterprise system should be focusing on. This is where you should be spending your time, coding this stuff, not all the other stuff, not object relational mappings, not configuring Kubernetes, not doing your caching and fine-tuning this and scaling that. This is where developers should be focusing. Wouldn't it be great if we had a powerful, fault-tolerant, reactive, streaming system which was made distributed first to do this? It was designed to do this, and it was scalable. And we could just focus on those things I mentioned. Do you think that would allow us to delete 90% of your code? Some people nodding, others maybe not so certain. Remember here too that when we talk about deleting 90% of the code, we're talking about not just the code, we're talking about the infrastructure components. Can we get rid of containers? Can we get rid of Kubernetes? Talking about system components like databases. Can we get rid of a database? Development stack. Can we get rid of ORMs and all the configuration and stuff that revolves around them? Can we have less complexity and definitely less glue code? The system should know what we want to do and know these are the core parts. It can glue it together and do stuff for us. Maybe if we delete all of those things, maybe we can get rid of 99% of our code. Hope so. So the promise here is to fix enterprise systems, to show you a new way of building enterprise systems which is a lot easier, which is a lot quicker, a lot more performant and more fault tolerant. To this end, I'd like to introduce you to the Rama platform. To be clear again, this is not my platform. It was created by Nathan Mars and is a product of Red Planet Labs. We'll talk more about that. But this is the platform, I think, which solves these problems. And I want to explain to you how it works. What actually is the Rama platform? Well, it's a distributed first, means it's built to be distributed. It's a reactive platform, so it always responds to things when they come in immediately as soon as it can, for building highly scalable, fault-tolerant enterprise backend systems without the usual complexity and mess. That's the promise. For developers, we'll see it offers a unified programming model, 4 core concepts, which covers just about everything you need to know. It's written or you develop in Clojure, which is Lisp on the JVM, or Java, and it uses a Rama API. For deployment, you basically deploy on a number of servers. You don't need Kubernetes or containers. It runs on a cluster of servers. It provides control and observability and enables updates to your code and also backups of the data. Basically, Rama runs as a cluster. It can be a very large cluster, hundreds or thousands of nodes, but it behaves like one system. You don't need to worry about each node individually. So the question is, how do all of these essential components we talked about, the 4 things, how does Rama do each of these? I want to explain these briefly to you. And this is what the focus is in Rama. The first one is the command bus. Rama calls these depots, but just think it's a command bus. It's basically an ordered log, a write-only ordered log, very much like pub/sub topics in Kafka. Persistent, durable, partitioned, replicated, handles incoming events and commands, but also outgoing events and commands. So depots, just think pub/sub for commands. The second part of the Rama is the command handlers. And these are basically the Ziggy lines here. These are streaming data flows. They're the ones that look at the depots and say, there's another command in there for me now. I'll take that command and I'll update the persistent state if it's a valid command. And as you can see here, I've drawn the data shapes that will update. There are a number of different shapes of data. We'll talk more about that soon. So the command handlers are basically a process that handles commands and events from the depots and updates the persistent state as needed. They're fault tolerant, they're distributed, they're reactive by design. The system ensures that. You just write the code for these command handlers and you get all the rest of the stuff for free. So these could be basically command handlers that take our banking commands and process them and update your balance or something like that. The third part was queries and views. Rama calls them queries and views, which is nice. They're declarative, but they're not SQL. Also importantly, they're live and streaming. The whole of the Rama platform is a streaming platform. So when you get a query, you get the answer back, but you also get a subscription. So when that changes, you get the update. So your application, your front end can just log into that subscription and automatically notified when changes happen to that query. So it's live streaming of the queries. This is a lot like Redis and that sort of stuff, read caches. As you can see here, the different shapes are the different shapes of our views tailored to the queries. And the arrows, the queries come in, but they're streaming out the answer to the query. It's a streaming subscription type query. The fourth thing was event processing in Rama. Rama just uses the depots. They're not just for incoming commands. They can also be used for events, and they can also be used for outgoing commands or outgoing events. They're basically the write-only log, which is a common thing to use in enterprise systems these days, again, like Kafka. So they're the four parts of Rama, and they fit together in this streaming platform like this. So again, the commands come in, they're captured in the depots. The topologies here, as Rama calls these flows topologies, fancy name to say we just take the data and we process it and we update our persistent shapes, our persistent data. And on the other side, you have the queries coming in, which are reactive to changes to the persistent state, create the views, produce the answers. This is the focus of Rama. Everything there is to support this. And each of these parts, as you can see, is partitioned, replicated, durable, fault-tolerant, as needed, automatically. Talk a bit more about persistence here. Rama base, as I mentioned, has these things called p-states, or persistent states. They're basically data stores tuned to what you want for your data. They shape according to what you need. They're partitioned, they're replicated, and they're durable. What do we actually mean? Well, in traditional databases, you get some options. The data model the database gives you. It's a relational database, or it's a document database, or it's a time series database. And you have to map your data model from your application into this data model. How do I take my data model of object orientation and put it into a relational model? Oh, that's going to be complex, and a lot of work there. That's why you use the ORMs. Rama takes a different approach. It says we want our persistent states, our p-states, to use data structures exactly like we would need for our data model. So you build your data model using these data structures, like index and map. And basically they're composable, so you can make any data model you like. They're also distributed, partitioned for performance, and replicated for fault tolerance automatically. To give you an example, a relational database, its data structure is something like an index of a table of rows. That's basically what it is, plus the query structure. A document database is like an index of a map, a documents map. So we can build all of these database data models in Rama just using these data structures. Similarly for a graph database, and even something like Elasticsearch. A simple data model inside our system can replace the data model of Elasticsearch. So Rama uses p-states, which are just data structures, but they're durable and fault tolerant. These are, as I mentioned, composable. This is where you get the power from, composing things from lots of simple things. They're very flexible, and it's a unified model for all of your databases or all of your data structures. Rama is also very different in how it handles computation. In Rama, the data and the code are co-located together. What do we mean by this? Well, traditional databases or traditional applications, how they work is when you need some data in your business to actually change things, you go to the database and you fetch that data, you update the data, and then you write it back to the database. Very slow and stuff because of the database and hopping across the network. Rama takes a very different approach. Basically, it has the different nodes, and a node will have the depot required for certain customers or bank accounts, the topology code for that customers or bank accounts, the state for those customers or bank accounts, and also the queries for those customers or bank accounts, all on that same node. And they're partitioned across a number of different nodes. So the code is already where the data is. There's no need to get the data, take it and put it back and so forth. It's just there. This makes Rama very performant because it's basically operating on data in memory. But you have to do a little bit of work to find out where is my particular customer, on which node do they exist. And once you've found that, then you can actually execute the code. So updating and changing p-states in Rama is a two-step process. You navigate through your data structure. So I have an index of a map. I have to go through this to find where is my customer in this. And we use a path-based approach like Spectre, Closure Library users, to specify what's the path to get to my data in this data structure. And then you basically can read and update that data. So once you've found your data in the big data structure, you can say, I want to increment this data, or I want to change the value. Or you can even transform a tree of data using functional operations. It's all done by composing familiar functional operators. And again, all of this is streaming, fully distributed, and fully fault tolerant. So also composable, flexible, and unified, as I mentioned. One way of handling updates to all different data structures. And it's very flexible. So what about Rama development? The only things developers need to focus on in Rama is writing what are called modules. And think of modules as like a microservice. So a separate team can work on their own modules. Basically what they have to do is define the depots, what will be our pub/sub topics, what will be the formats of the messages, define the P states, what data structures do we need for this business data, define the topologies, the flows, when a message comes in, how do I change my P state? And define any queries and views we want for those particular data. So we write up a module with this code in it, nothing else, and basically we deploy that to the Rama platform. So independent teams can develop their code independently and deploy it independently like microservices, but it's on the Rama platform. Just quickly, the Rama platform for deployment, basically, as I mentioned, is just a number of nodes. Most of the nodes are called supervisor nodes, which actually run the tasks and so forth. And there's one conductor node, or many conductor nodes, which handle updates to the code or backing up and so forth. But the real work gets done on the bottom nodes. And as you can see here, we've deployed a number of modules, the green ones on a couple of nodes and the orange one on a couple of nodes. We get the redundancy there, the backup, the fault tolerance, but you also get the performance. So this is the Rama deployment model, and it's sort of very different than traditional deployment. In Rama, you only have these conductors, the supervisors, and you're all about deploying a module. No need to worry about tuning my database or getting the ORM mapping working or making sure Kubernetes is working properly. It's one-click deployment, and it handles scaling and failover automatically. So developers can focus on the business logic inside their modules, not need to worry about anything else. Compare this to traditional development, the complex mess we talked about. Right? You have to think about orchestration. Let's configure Kubernetes or Mesos, and messaging with Kafka, and databases. Let's update Postgres, and let's change the data model, and streaming and so forth, and develop a glue code, write the ORM and so forth. Lots of work you're doing there which you don't need to do on the Rama platform. There's also lots of operational burden here. I'm going to scale my database. Do I need to scale the applications? How do they relate? And there's separate things to work about. And there's complex failure modes. And there's lots of boilerplate code we need to do. So Rama deployment is, again, dramatically simpler than other types of, or traditional complex massive deployment. Rama is not an all or nothing decision. Rama can integrate very well with other applications you have in your organization, through the pub/sub, through the events, through the query APIs, and can also integrate with external systems. So you can start off with a small part of your system using Rama and use more and more later on. So what about the pros and cons of Rama? Well, hopefully you see it's a massive simplification, dramatically fewer moving parts. It offers scale and speed and durability. It's one system, the Rama cluster, not many 10 systems, Kafka and Postgres and Redis and caches and glue code. Computation and state are together, so there's no need to move the data around. You operate on it where it is. It's this always live and streaming platform. And very differently, it was designed from day one to be distributed. It's distributed first. You've heard of mobile first. This is distributed first. It was also designed from day one to be streaming. So streaming first, everything's streaming. It's crash-proof. There's less code, more of your business logic. As I mentioned, the modules are sort of like the microservices. Basically, operations is all provided with the Rama cluster. One ops in one box, very easy to do, to update your things. They even have instant migration. So you change your data structure, Rama will instantly help you migrate that data from one data structure to another. So no more versioning of your database tables and schemas and so forth and updating the data. Rama handles that instantly for you. There are some cons, of course, to any platform. Rama is a new platform, it's quite young, so the ecosystem is still developing. Although it's been in development for 10 years, it's a mature technology and it's used by companies now. There's a different mindset. There's no SQL, so if you're really invested in SQL, that's your do. Well, this is maybe not for you, unless you want to learn something new. There's no microservices. It does use Java or Clojure, as I mentioned, and takes a declarative, functional-like approach. I wouldn't call it functional programming because there's not much programming you really do. There may be a smaller talent pool currently available to do this, but I think any smart developer who's keen to learn could embrace Rama very quickly. There are some integration gaps still. Thank you. And also you have all your eggs in one basket. You're going with this vendor, so you're sort of locked into the vendor if you take this approach. It's a trade-off you have to think in your organization. And the last one here is probably the biggest. There's a license fee. Okay? They provide free access to a 2-node deployment. That's 2 nodes plus the conductor, which you can very easily run a small to medium application on. They don't say the nodes have to be so many CPUs or what. You can have really grunt-size servers. So 2 nodes for free, but then after there's a commercial license for Rama, and you can see the pricing on the website. I'm not involved with that sort of thing. So it's a trade-off, of course. But to me, it's a dramatic improvement in enterprise systems development. Maybe this trade-off is worthwhile. So get back to the payoff here. How are we going to actually prove it actually works? Does this, I've said delete 90% of your code. Does it really do that? So let's first of all evaluate the qualities of Rama. Remember this diagram before? The things up the top we want to be green. The things up the bottom we'd like to be, we have those. Rama comes up really good in all of these areas. As I mentioned, you get scalability by default. You get fault tolerance by default. High availability, durability, resilience. All of these comes through quickly. Consistency there is about consistency for data. Rama does have some eventual consistency built into it. And elasticity, at the moment, there's no easy way for Rama to scale the cluster automatically up or down. But maybe that'll be coming in a future release. As you can see, it offers many of the things you require down the bottom here. To provide those things, Rama platform provides it for you. Distribution, replication, all those things. What about for developers? All the things developers look for in a platform. If you evaluate Rama, it comes up great as well. A very consistent platform. Very easy to maintain. Clarity in the concepts. Very productive platform. Easy to test. Easy to observe, easy to refactor. There is some work in the learning curve, of course. It's a different way of doing things. And it could be a bit more simpler because it's a change in paradigm, so it's to think about things a bit differently to start off with, but nothing we can't overcome. Portability there, it's just on the JVM, but it runs anywhere the JVM runs, so that's, I think, quite portable. So that's really good, but delete 99% of your code? Well, still, we've got to check it out here. So what about messaging and streaming subsystems? Who here enjoys configuring Kafka, setting up the topics, updating Kafka when the new release comes about, changing the configuration files? Anyone enjoy that? No, oh, one person does. I don't. I say delete them all, okay? What about the database and storage? Who likes doing the ORM mapping or updating Oracle or configuring the data schema or fine-tuning the database, putting in NoSQL databases? I say delete them all, okay? Get rid of them. What about the middleware, object relational mapping? If your data structure in your memory actually maps exactly to what your persistent store is, you don't need object relational mapping or tools like MyBatis or temporal workflow engines. Delete them. Are you with me? What about analytics? Have a separate system to do analytics. You have to extract and transform and load your data. Materialize views so your queries go. What are we going to say? Delete them, okay? What about things like edge case? Oh, we need an extra graph database, or we need an event store, or we need some more monitoring stuff. Extra things to configure. What should we do with those? Delete them, okay? Get rid of them. What about caching layers? Oh, we have to put a cache in because the database is too slow, or the front end needs a cache. We have to put in materialized views. Let's delete them as well. And you can go on. What about containers? Yeah, Docker's nice technology and Kubernetes. Docker's good and so forth. But do you really want to spend time configuring Docker and downloading images and setting it all up? Let's delete them too, hey? Get rid of them. And what about orchestration? Oh, Kubernetes is very popular these days. You've got services and stuff and it scales automatically, but it's more configuration, it's more hassle, and it's more cost. Okay, you pay for Kubernetes services maybe, it's complex. Let's delete that as well. I think you can keep on going, you can delete lots of stuff. Or your glue code, your tooling you need to run liquid database stuff and fly away to migrate your database structured data. Delete them, fault tolerant system, delete them. Delete all this stuff. Basically, Rama is a platform which collapses all of this functionality, the stuff that's left, into a simple platform that does most of the work for you. Can you delete 90% of your code? What do you reckon? Still not convinced? Okay, let's look at a case study here. Basically, a case study says, let's look at Twitter. Rama worked at Twitter, and this was their platform that Nathan worked on, sorry. Twitter didn't use Rama. Twitter backend is about 1 million lines of code. And it's evolved over the years. Oh, we need a new data model for persistence, so we create our own custom data stores. Not just Redis or Neo4j or whatever, custom data stores. And they tweaked it and so forth to reach the scalable and performance. 1 million lines of code, but it is scalable, distributed, and fault tolerant, which is great. If we look at the other side of things, Mastodon backend is approximately 16,000 lines of code. It's a free and open source implementation of something like Twitter, but it's a federated system. It's not scalable, it's not fault tolerant. You run your own little Mastodon servers. It's about 16,000 lines of code and written in Java as well. So what Red Planet Labs did was they tried to implement a scalable version of a Twitter-like system, fault tolerant and scalable. They did that. It took them 9 person months, whereas Twitter took approximately 200 person years. Facebook, when they developed Threads, took 25 person years. They developed this system in 9 months, and they performance tested it. They used 100 million bots with 3,500 posts per second. And one of the things about Twitter which makes it so hard is some users have 10 or 100 followers, or following 10 or 100. Others have millions. So that makes the data model very, very difficult to do. But Rama could do that. It used its own custom data models as needed. They implemented, how did it go? Well, this is what it looks like, and you can access it on the web. It's in GitHub, you can download the code, you can see the code they wrote. It scales linearly. It means you want more scale, add more nodes. At around about 80 nodes, they get to the Twitter scale of performance. So 80 nodes in a cluster can do what Twitter does. And they can go way beyond that because it scales pretty much linearly. Amazing, this platform does that. But what's the punchline here? The punchline, I left it out on the last one here, is how many lines of code that they did. It took the Rama platform 10,000 lines of code to develop a Twitter-like system which was fully scalable, fully fault tolerant, and easy to develop on. 10,000 lines of code compared to 1 million lines of code. That to me is the payday. That's 100 times reduction in the code. From 1 million lines to 10,000. It's just the stuff you need to focus on, not all the rest of the stuff. To me, that shows how brilliant the Rama platform is. So hopefully, delete 90% of your code. Hopefully that's sort of proven now. We can get rid of all the other stuff and focus on just that one line, or the 1% of code, which is really the business code. To wind up here, just quickly, a couple of minutes. We've seen that we've seen the pain of back-end development, the complexity, all the systems, burying all your business logic in endless infrastructure. We've seen the promise of Rama, and we've seen that it pays off with 100 times less code or better performance or so forth. There are a number of other case studies which show we've got 100 times better performance by using the Rama system. We developed our system in 1 month, which would normally take 10 months or 10 years to develop. So lots of improvement in productivity. I just want to look at the front page of Rama now. Again, I'm not promoting the company or anything here, but just hopefully you understand what they're saying on their front page now. They say infinite data models. Hopefully you understand. We're not limited to a relational model or a tree database model or a document data model. We can build any data model we need to fit our business. Infinite composability. We build things by composing other things in the functional way. It's not rewriting everything from scratch. And infinite scalability, as we saw. Just add new nodes. If you'd like further information, you can go to the Red Planets Labs.com website. They have lots of documentation. They have a great blog which describes the Twitter implementation. As I mentioned, the Twitter implementation is on GitHub. You can download it. You can read the code. Many other examples there too. There's a Slack channel. There's a couple of YouTube videos where Nathan gives presentations. And you can actually download and run the Rama platform very easily. It's a small download. Install it on your servers. You have a Rama cluster. You can deploy your modules. So just thinking back to my failed startup. This almost brought a tear to my eye when I was reading through the blog. One of the things what the blog said was, there's no reason the tooling you use to most quickly build your prototype, your MVP, should be different from the one you use to build your application at scale and fault tolerance. So perhaps, if I had Rama back then, my startup may have succeeded because I wouldn't have been wasting all the time doing all the other stuff. So that's basically all from me. Are there any questions? Or if we have time for questions, I'm not sure. But thank you for your attention.
Great, thanks very much. Did we have any questions? Yep, I'll come to you.
I'm not an expert, so hopefully you can answer the question.
Thanks for your speech, Ashley. I was just wondering, because Rama seems to be very event-driven, for applications where they're very performance-sensitive and real-time, how does it handle that sort of situation?
Performance-sensitive?
Yes.
Yeah, of course. This is the whole thing about being performance-sensitive. I did say it wasn't focused on hard real-time systems, but because everything's streaming, when that next command comes in, your system is processing it as soon as it can, and the queries are being updated as soon as they can. It's more performant than traditional systems. This flowing through, the data flows through, the queries flow through, and also because the code and the data is distributed on the nodes, everything's done distributed. You don't have to both query the database. The data's here, your code's here, your code's here. It's running at the same time. So very performant. Performance is one of the top features of the platform. But maybe I need to convince you a bit more.
All right, we've probably got time for one more. If
there's one here.
Where, sorry? Oh, there you are, Luke.
Awesome talk, Ashley. Thank you so
you.
much. Yeah, just on the back of performance, I was just curious about concurrency. Do you have any insight around how concurrency works?
Sure, absolutely, absolutely. So again, this gets back to this. Think of your customers. One customer lives on one node, and their bank accounts are on that node, and the code is on that node. So basically, it's highly concurrent. Different customers on different nodes updating at the same time. And when you write the code for your module, because you're handling one command at the same time, it's like single-threaded. You don't have to worry about concurrency at all. No concurrency. You just say, hey, I've got this whole lot of customer data, and I can do my transformation. And when you're finished, you hand it over to the next processing of the customers. So there's no concurrency stuff, messy stuff to make it complex and difficult. You think of it as a single-threaded application you write. Good question, though.
Great. Well, that's probably what we have time for.
Thank you very much.
Thanks again very much to Ashley.